Hello, everyone. Welcome to another edition of Water Wednesday. My name is Shah Tariq. I'm with the City and County of Honolulu Stormwater Quality Division. Today, we're going to do the activity Color Me a Watershed. This is to recognize how population and settlement growth can cause changes in land use. Through interpretation of maps, we will observe how development can affect a watershed. This is part of Project WET. It's an activity in their curriculum guide. Project WET stands for Water Education for Today. Project WET's mission is to reach children, parents, educators, and communities of the world with water education. Project WET believes that informed people are more likely to participate in the decision-making process and to make a difference through their actions. Color Me a Watershed is geared to grades 7 through 12 and touches on the topics of environmental science, math, history, and anthropology. We host this presentation or a similar presentation every 2 weeks. You can find our previous presentations on our YouTube channel, and more information is on our Facebook page. By the end of this presentation, we'll have links to the websites. And also, if you are following along on YouTube, in the description, you will find links to the activity sheets that we will be using. So our agenda for this presentation, first, we're going to go over what a watershed is, the importance of watershed maintenance. Then we're going to take a look at what Hawaii looked like in the past and compare them to modern day pictures so we can see how watersheds have been affected. And then we'll do a couple of fun activities regarding watersheds and settlement growth. Our goal is to recognize how population growth impacts land use. So what is a watershed? A watershed is an area of land where all the water that is under it or drains off it collects into the same place. Water from hundreds and often thousands of creeks and streams flow from higher ground to rivers that eventually wind up in a larger water body. So imagine all of the rain that falls on these steep mountains in the distance. When water hits the steep surface, there is only one way for it to go, downhill. Gravity pulls water downhill as fast as it can, taking the easiest path it can find. This water, including melted snow, eventually comes together as runoff to form small streams which meet other streams further down, and so forth until a river is formed. So where's all this water going? Some of it seeps into the ground to form groundwater. Some is used by people and animals and then recycled, but most of it flows until it reaches sea level, which is usually the ocean, but can also be a larger lake. This is a challenge that we're all facing because what do you think happens to the water as it passes by all the farmland, homes, and factories that you see in this image over here? Human interaction with watersheds produces contamination and pollutions that make their way into our larger bodies of water. This is how our debris and plastic make its way into our oceans. In fact, 80% of ocean plastics come from land-based sources. So, the importance of watershed management. Learning about the past refines our current perspectives and helps us plan for the future. Through the interpretation of maps, we can observe how development can affect a watershed. Historical maps provide graphic interpretations of watershed history. So by comparing past and current land use, we can recognize trends in development. Later on in this presentation, we will do 2 activities together, and hopefully by the end of this presentation, this will be more clear. Last thing I want to mention on this slide is GIS. So people are using geographic information systems, GIS, to store data and generate land use maps electronically. No. Sorry, does it work now? The last thing, I'll repeat the last thing I said. The last thing I want to mention on this slide is GIS. People are using GIS to store data and generate land use maps electronically. This is significant because people could generate a map that shows a river's watershed and major tributaries, its floodplains, and the locations of urban dwellings to display areas likely to be impacted by floods. So this information is super valuable to planners, homeowners, realtors, etc. So the city and county of Honolulu have a GIS website. It developed one of the most comprehensive GIS databases and GIS maps of any municipality of its size, the Honolulu Land Information System. So to access this, you can visit www.honolulugis.org. So we are going to start our first activity, Color Me a Watershed. So utilize the link in the description. What you can do is you can either print out the activity sheets and get some crayons and pencils to follow along, or you can take the document and open it with paint, and you can follow along that way, and you can paint online electronically. So this activity is called Color a Watershed. Think of a city that you're living in and imagine what it looked like there 100 years ago, right? Then we're gonna color the squares of the activity sheets by the land type on the board. But before we do that, I will show you some pictures of Hawaii from the past compared to the present. So comparing the pictures on the left and right, you can see how much has changed. The image on the left, there were no buildings or streets, and the building on the picture on the right shows an established residential area. So over here, water used to have a direct path down from the top of the mountain to the bottom, but now it has to go past all these buildings and paved streets, picking up contaminants and pollutants on its way to the ocean or another body of water. A couple of other examples. This is of Waikiki. So same thing here. You can see how water has to go through all of these buildings before it makes its way into the ocean. One last image that shows a very similar thing. In the past, whenever there was rainfall, the water can come past these mountains here on the image to the left and make its way into this body of water. But now it has to go through all of these buildings and residential areas before it makes its way down, and again, picks up pollutants and contaminants on its way. So now we are going to start this activity. So again, the link will be in the description of the YouTube or Facebook video. And I'm going to add it one more time to the chat if you want to follow along. And you can have some crayons and follow along just coloring by yourself, or you can do it digitally as I explained a few minutes ago. So when you open up the activity sheet, you will have maps A, B, and C. They represent an aerial view of a watershed at different times. Map A from 100 years ago, map B from 50 years ago, and map C will be the present. So the maps represent a change in this land over a 100-year period. So look at the key for each map which is going to be on its right-hand side, and designate each land area with a different color. So for example, we can color the forest green, or you can color it whatever color you want. Just the most important thing is that you keep the same color scheme for each map. After that, we're going to compare the sizes of the different areas on each map. You know, we can compare plant cover or how much residential area this is and so on. So at the end, we'll be able to note the changes. So this is map A, and I'll show you an example of how you can kind of paint this digitally. So I opened this on Microsoft Paint. I won't color in the whole map, but I'll show you how we can do it together. The easiest way is to get this paint bucket icon. Let's say I'll color the stream first. And then you can go along each box and paint it. It doesn't work the best digitally, but you can still do it. So another way you can do this is you can get the brush icon. And let's say for the forest, we can paint some of these green. And then you can just like make a little circle here. To symbolize it that way. I'll just do a couple of each and then we will move on. So pay attention when you're comparing map A, B, and C, just pay attention to all of these grids that we're coloring. And then you'll see changes through time of certain areas getting bigger and certain areas getting smaller. I'll just paint a couple of wetlands and some residential areas, and we'll move on to the next slide. So I have a fully painted map A in the next slide, so you can just see it. So I'll keep going. So this is map A. No, before it was colored and after it was colored. So it looks, and we'll go through each map, map B and map C. Now, when you look at them, comparing the two, just pay attention to how the forested area is getting smaller while the residential area is getting bigger. Same thing with map C. And then we can look at them all side by side. So comparing all three maps, you can really see the gradual change over the 100 years. All the forest, grassland, and wetlands have decreased in size, while the residential and agricultural areas have increased. So you can see right over here, this grid used to be predominantly forest, and now it has decreased with every 50-year increment. So now the residential area has increased while the forested area has decreased. So this is just comparing map A and map C. So a couple of questions. So the first question you can answer on your own is, what happens to the amount of forested land as you go from map A and map C? I already actually answered this one, but as you can tell, the forested area is slowly decreasing as the residential area and agricultural area are increasing. Which map, question 2, which map has the most land devoted to human settlement? The answer to that is also map C. You can see on the grids over on the right-hand side um, how the brown area that we designated for residential has increased significantly from map A. In map A, it was on pretty much the bottom left area, and now it's on the bottom left, the bottom right, and the top side of the map. The same thing with agricultural areas. It used to be for maybe 10 square grids, and in map C, it is much, much more. So question number 3, where are most of these human settlements located? So if you can tell by the map, most residential and agricultural settlements are by a body of water. And what this does is that, one, it shrinks the forest and the greenlands. Two, it contributes more to water pollution. The more human interaction with waters increases pollutants and contaminants and plastics. And like I mentioned before, 80% of all plastics in the ocean come from land-based sources. Now, last question, what effect might these human settlements have on watersheds? So I mentioned it before with how much more an increase of pollution and plastics make its way into the ocean, but there are other things that are affected. For example, animals living in their ecosystem have to be forced out and go deeper into the forested areas. Their access to water source has also been depleted. But for what we are focusing about in this presentation is how plastics and pollutants and human pollution really makes its way down from these watersheds because of human interaction and slowly pollutes the ocean. So activity number 2, find the land area. So for each map, now we're going to determine the land area occupied by each type of land coverage. So we're going to find how much forest land there is, how much wetlands, and farmland. Each unit in a grid, so each 1 square kilometer, each 1 square kilometer is equivalent to 1 unit in a grid. So there is a total of 360 square kilometers on each map. To determine the percentage, we divide the number of land type units by the total number of units, 360. So for example, to determine the square kilometers of forest, we simply add up all the forest units. So in map A, if we counted all of the forest green areas, it will add up to 189. To determine the percentage, divide the forest units, which is 189, by the total number of units, 360, and then multiply it by 100. So if you do that, 189 divided by 360 times 100 gets you the percentage, which is 52.5%. So let's take a moment. I'm going to pause for 1 minute and let's see how much we can fill out. If you're watching this at home on YouTube, you can just press the pause button and fill out this grid by yourself because the next 2 slides will have the answers. I'm going to flip over to the grid so you can have a look at that too. So again, to figure out the square kilometers, you just add up all of the units for a certain land area. So to find out the agricultural land in map A, you just count all of the orange boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 square kilometers. For the agricultural land, it'll be 10 square kilometers for map A. So now I'm going to flip over to the answer sheet. So I figured we could do these two together. So we have the grassland at 20 square kilometers. So we want to find the percentage. What we do is we take this 20 divided by 360 and multiply it by 100. If we do that, we get the percentage to be 5.5%. Same thing with the wetlands for map C. We'll take this map number 5, we divide it by 360, and then we get our answer to be 1.3%. So when you look at this chart, does anything kind of stick out? Anything that seems out of the ordinary? Because to me, when I look at this, I look at the forest, and in map A, 100 years ago, the forest used to be 52.5% of the entire map. And then 100 years later, the forest is now only 30%. So it went from being the majority to being in the minority. We had someone comment and said the stream land area never changes, and that's true. The only thing that's been consistent on this grid or on these maps is that the stream stayed at 111 square kilometers from map A, map B, and map C, which is about 30.8%. But one thing I also think is interesting is that the forest, the grassland, and the wetlands have significantly shrunk over the years, while the residential area and the agricultural area have increased. So you can see here the residential area increased from 3.6% of the entire map to 16.1%. So I'm going to go over to the next slide. Okay, so for additional homework, if you are interested about this topic, the next step you can take is to draw a forest map and use this map to reflect what it would look like 50 years from now. And then take a note, does the residential land increase or does it decrease? Is the stream affected at all? Or is the agricultural land increasing or decreasing? Step 2 is this time plan a city that contributes positively to a watershed. So think about where the residential areas and agricultural land will be placed in relation to the body of water. Next slide. So, thank you all for participating. If you have any questions, you can send us an email at cleanwater@honolulu.gov. There are links to our Facebook page and our YouTube channel on the slide. So please follow us on both, and we will see you here in 2 weeks. Take care. Have a good day.